Greetings, fellow code adventurers. Ever feel like you're lost in the matrix when someone starts talking about computer science? Well, fear not. Today we're unlocking the secrets of conceptual models, brought to you by the BSCS students of TUP Manila. Think of these models as cheat codes for understanding complex systems. They help us break things down, see the big picture, and ultimately build better software. So buckle up. This will be fun. Here's the roadmap for our adventure today. We'll be checking out 5 key conceptual models, each with its own superpower, and we have assembled our team for this adventure. First, we're diving into the world of client-server models with Reichel. He is bringing his code wisdom to simplify this system. Then we have Elijah bringing light to layered network models, followed by Elisa breaking down finite state machines in a fun and digestible way. Next, Julius will unveil the object-oriented programming, and lastly, Mark will tackle the data flow diagram. Let's start off with Reichel and his explanation of the client-server model. You are in the right place. Let's say the client-server model works with restaurants. You, the customer, ask for what you want to eat, and then the chef makes it for you. What makes the restaurant run? The client who asks for the meal. The server who performs the task asked by the client. The network, which connects them. The protocol, creating a standard way to communicate. Since all those components are crucial, where is this being used? Web browsing, email, and online gaming all use the client-server model. For example, when you bank on your phone asks what can be done. When you watch Netflix, it sends you the information. When you play Valorant, you connect with friends. In essence, the client-server model is all about dividing tasks and managing resources efficiently across a network. It's what lets you binge-watch Netflix or scroll through social media without everything crashing. Thank you, Reichel, for explaining the client-server model. Up next is how layered network model. Are you ready? Let's hear more from Elijah about layered network model.
So, let's say that you want to know what does it take to connect to the internet. Since most of you are new, it's going to blow your mind with all the data. When you send something through the internet, here are what make it up. We have the application of what you are using. We present different details on what it is. Each connection goes through a session. Data is transferred through transport. It always flows throughout a network, and will always data link from you to the service. That also gets transferred to physical. So the real question is, what does this thing do? These are often used for the design of protocols, for troubleshooting different errors, and to learn more with the network. To have safety, we implement security to allow people to view without breaches. In simple world, to send email, we need all those layers. If we want to visit a site, we need those layers, or video call where we can see each other. The layered model simplifies network architecture and promotes interoperability through standardized functions at each layer. It's the reason your emails arrive mostly in one piece.
Thank you, Elijah, for helping to better understand the layered network model. It can sometimes be a headache, but it is also the greatest connection. Now for something less complicated, but just as complicated, the finite state machine model. So buckle up as we dive deep with our
Next is the supermodel. It is a laser that can explain the intricacies of finite state machine. Have you ever wondered what does it take for machines to work when interacting with you? What does make these things functional in our everyday lives? These have different states, takes different inputs based on your actions, transitions to either go to the next state or to decline you. It all starts with the starting point. And often it will all end with accepting states. With those states, inputs, transitions, start and end. It is often used for machines in analyzing the code. AI so we can create more advanced things. Follow instructions to have different results. Here are some more examples to enlighten you. Machine in controlling traffic. Elevators to let you move floor to floor. Machines that let you take products in exchange for money. The FSM model is useful for modeling discrete systems that operate through a series of states and transitions. It's the brain behind everything from traffic lights to your favorite video game boss. Thank you, Elisa. I sure wonder what happens behind machines. Now to change the pace, let's go to coding. But what about it? That will be the world of OOP with Julius. Let the stage light shine on the OOP model. Hey everyone, today I'm demystifying object-oriented programming, or OOP, using something we all love, Legos. Imagine coding like building with Lego bricks. Just like each brick has a specific shape and function, so do the components of OOP. First up, the basic building block, classes. Think of a class as the blueprint for an object, like a Lego instruction manual. From these classes, we create objects, just like building different Lego models from the same set. Classes have attributes, which are like the color and size of the bricks, and methods, which are the actions these objects can perform. So, why use OP? It's like creating a collection of Lego sets for different purposes. You can build software that makes life easier, develop games with interactive objects, and design sleek, user-friendly interfaces. All of this by using reusable modular components. Cool, right? Let's look at some examples. Take a game, for instance. You'd have player, enemy, and item objects. Or in e-commerce, a product class for different items in a store. With OOP, you can mix and match these objects to create complex applications. It's efficient, organized, and makes your code a lot easier to manage. OOP promotes code reusability and simplifies software design through modular components. It's how developers create everything from intricate software applications to your favorite mobile games. Thanks, Julius, for breaking it down. Those Lego blocks truly bring coding to life. And now let's dive into our next topic, data flow diagrams. Stay tuned. Remember, coding is all about breaking things down into manageable pieces, just like Legos. Keep building and happy coding.
And to end the presentation, let's dive to Mark and he will show us a map on how data flows. Here we are again. And let's dive into what makes everything here work. A data flow diagram, or DFD, is a visual representation of how data moves through a system. It includes processes, data stores, data flows, and external entities. What makes it work is the process, which is the backbone of any data flow diagram. It starts from identifying the key entities, which are the fundamental building blocks. Follow the process meticulously, ensuring each step is clearly defined and all actions are accounted for. Determine where you should store your data, whether on local servers or in the cloud. And finally, map out where the data should flow, ensuring a smooth and efficient transfer. Where is it often used? These models can be used to do system analysis, learn all data in the information, follows all the business processes to learn more. In real life, we see this in a lot of ways. For example, in a hospital, a DFD can map out patient information flow from registration to treatment. Like a restaurant when you have to follow a system, libraries when you search for a certain item, and to enroll in schools where information is being passed around. DFDs are used for systems analysis and visualizing data movement in information systems. It's how you map out a complex process and make sure everything is flowing smoothly. That was really amazing, Mark. You've reached the end of the path. Thank you, Mark, for giving us what we needed to do to flow and to have a great process. To keep the points to remember are, if there are requests, then make sure their needs are heard. Always. Listening to your team and understanding their requirements is crucial for success. Make sure the data follows the layers. Each layer has its own importance and role in the process. You can only press buttons, but remember, each press can lead to significant outcomes. And always think about the machines. They are the backbone of our operations, ensuring everything runs smoothly. Legos for codes you can always create with Lego for different times. Just like Legos, coding allows for endless possibilities and creativity. Follow the road that we mapped out. This path is designed to guide us to our ultimate goal, ensuring we stay on track. These are all amazing models that can lead us to help more. Let's dive deeper into all of it. Thank you to Reichel, to Elijah, to Elisa, to Julius, and to Mark for showing us a new planet. Your contributions have been invaluable. We would like to thank you all for your time in hearing us. Your support and enthusiasm have been crucial. It's an amazing and important work. Together we have achieved something truly remarkable. And now, it's time to make the new world. Let's build a future that we can all be proud of. Congratulations, you are now code pioneers. Your journey has just begun and the possibilities are endless. Do you have any questions?